Good morning, students. In the previous class, we discussed about the classification of periodic table into blocks and also the merits of long form of the periodic table we are discussed in the previous class. In this class, we are going to be discussing about what is meant by actual nuclear charge, effective nuclear charge, screening effect. These are all we are going to be discussed in this class. The first we are going to be discussing about what is meant by actual nuclear charge. This is going to be represented by the Z. Actual nuclear charge. What is meant by actual nuclear charge? The force of attraction between the nucleus and the electrons in an atom or ion is called as actual nuclear charge. Means if you are going to be taken an atom, the nucleus is going to be at the center. The electrons is going to be revolving around the nucleus. The electrons is going to be revolving around the nucleus. These are the electrons. The electrons is going to be revolving around the nucleus. Actual nuclear charge means the force of attraction between the nucleus and the electrons. The force of attraction between the nucleus and the electrons is called as actual nuclear charge. Now we are going to be discussing about what is meant by effective nuclear charge. Effective nuclear charge. That is going to be represented by A. The effective nuclear charge is going to be represented by A. In this effective nuclear charge means the force experienced in the outer electrons. The force experienced the outer electrons by the nucleus of an atom. By the nucleus of an atom is called as effective nuclear charge. Is called as effective nuclear charge. Really, ಏನು ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಇರುತ್ತೆ ಎಲೆಕ್ಟ್ರಾನ್ಗೂ ನ್ಯೂಕ್ಲಿಯಸ್ಗೂ ಅದನ್ನು ನಾವು ಆಕ್ಚುಯಲ್ ನ್ಯೂಕ್ಲಿಯರ್ ಚಾರ್ಜ್ ಅಂತ ಕರಿತೀವಿ. ಮತ್ತೆ ಎಫೆಕ್ಟಿವ್ ನ್ಯೂಕ್ಲಿಯರ್ ಚಾರ್ಜ್ ಅಂದರೆ ಫೋರ್ಸ್ ಏನು ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಆಗುತ್ತೆ ಔಟರ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್, ಔಟರ್ ಶೆಲ್ ಅಲ್ಲಿ ಇರುವಂತ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನು ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಆಗುತ್ತೆ ಯಾವುದರಿಂದ ನ್ಯೂಕ್ಲಿಯಸ್ ಇಂದ, ಅದನ್ನ ನಾವು ಅಂತ ಕರಿತೀವಿ ಅಂದ್ರೆ ದಟ್ ವಿ ಕಾಲ್ ಆಸ್ ಎಫೆಕ್ಟಿವ್ ನ್ಯೂಕ್ಲಿಯರ್ ಚಾರ್ಜ್ ಅಂತ ಕರಿತೀವಿ. Then next we are going to be discussing about the screening effect. Screening effect or a shielding effect antanu karithivi. This also called as a shielding effect. This is going to be represented by yes, there is a screening effect or shielding effect. In this, what is meant by screening effect or shielding effect? The effect produced by the inner electrons. If suppose if you are going to be drawn the one more shell I am going to be drawing. This, the effect is produced by the inner electrons in the inner shell on the electrons on the outer shell. ಏನು ಎಫೆಕ್ಟ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ, ಯಾವ ಎಫೆಕ್ಟು? ಸ್ಕ್ರೀನಿಂಗ್ ಎಫೆಕ್ಟು. ಯಾವುದರಿಂದ? ಇನ್ನರ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆನ್ ಔಟರ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ and the outer electrons from the force of attraction of the nucleus. From the force of attraction of the nucleus is called as a screening effect. Screening effect means the effect produced by the inner electrons, inner shell electrons on the outer electrons, from the force of attraction on the nucleus, from the force of attraction of the nucleus is called as a screening effect. Means how it going to be effects? Means suppose inner shell contains the more electrons. At that time, it's going to be than the outer shell. The electrons in the outer shell. If the inner shell contains the more electrons than the electrons on the outer shell. At that time, what happens? The inner electrons is going to be shields the outer electron. At that time, the effective nuclear charge is going to be decreases. The effective nuclear charge is going to be decreases. At that time, it's going to be the screening effect is going to be shown by the inner electrons and the outer electrons. The force of attraction between the nucleus and the outer electrons is going to be decreases. Then the example classroom alli ella kutirtira ee first second bench alli irovrige matte teacher nucleus anta consider madidre students na bench alli kutiro benches na shells anta consider madidre bench alli kutiro students na ಅಲ್ಲಿ ನಾವು ಏನಂತ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡಬಹುದು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಂತ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡಬಹುದು ಇವಾಗ ಸಪೋಸ್ ಸೆಕೆಂಡ್ ಬೆಂಚ್ ಅಲ್ಲಿ 6 ಮೆಂಬರ್ಸ್ ಕೂತಿದ್ದು ಥರ್ಡ್ ಬೆಂಚ್ ಅಲ್ಲಿ 1 or 2 ಮೆಂಬರ್ಸ್ ಕೂತಿದ್ರೆ ಅವಾಗ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಎಲ್ಲ ಟೀಚರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಎಲ್ಲ ಯಾರಲ್ಲಿ ಜಾಸ್ತಿ ಕೂತಿರ್ತಾರಲ್ವಾ ಅವ್ರ ಮೇಲೆ ಇರುತ್ತೆ ಲೈಕ್ ದಟ್ ಓನ್ಲಿ ನ್ಯೂಕ್ಲಿಯಸ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಅಟ್ರಾಕ್ಟ್ಸ್ that is the inner electrons than the outer electrons ಅಲ್ಲಿ ಶೀಲ್ಡಿಂಗ್ ಎಫೆಕ್ಟ್ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ ಇಲ್ಲಿ ಇನ್ನರ್ ಶೆಲ್ ಇಂದ on the outer shell. At that time, that we call has a screening effect and that called as a screening effect. Now, teacher concentrate ಮಾಡಕ್ಕಾಗಲ್ಲ ಅಂದ್ರೆ ಲಾಸ್ಟ್ ಬೆಂಚ್ ಅಲ್ಲಿ ಇರೋ 1 or 2 ಸ್ಟೂಡೆಂಟ್ಸ್ ಮೇಲೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಮಾಡಕ್ಕಾಗಲ್ಲ ಜಾಸ್ತಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಎಲ್ಲಿ ಜಾಸ್ತಿ ಕೂತಿರ್ತಾರಲ್ಲ ಅವರು ಬೈಂಡ್ ಮಾಡಿರ್ತಾರೆ ಎಲ್ಲಿ ಥರ್ಡ್ ನೆಕ್ಸ್ಟ್ ಬೆಂಚ್ ಅಲ್ಲಿ ಕೂತಿರೋ 1 or 2 ಸ್ಟೂಡೆಂಟ್ಸ್ ನ ಬೈಂಡ್ ಮಾಡಿರ್ತಾರೆ ಅದನ್ನೇ ನಾವು ಏನಂತ ಕರೀಬಹುದು ಸ್ಕ್ರೀನಿಂಗ್ ಇಲ್ಲಿ electrons ಅಲ್ಲಿ ಸ್ಟೂಡೆಂಟ್ಸ್ just example I given. Then next we are going to discussing about the variation of atomic size. That is next we are going to discussing about the variation of atomic size. Variation of atomic size in periodic table. In periodic table. That is the variation of atomic size in periodic table. First, we are going to be discussing about the along the period. Along the period. First, we are going to be discussing about the along the period. We know that periodic table is going to be divided into 7 periods. Horizontal rows we call it as 7 periods and 18 groups. That is along the period. We are going to be along the period. The atomic number is going to be increases. The added electron enters to the same shell. Added electron ಏನಾಗುತ್ತೆ same shell ಗೆ ಏನಾಗುತ್ತೆ add ಆಗುತ್ತೆ. When it is added to the same shell, at that time the screening effect is going to be decreases. The screening effect is going to be decreases. Electrons outermost shell alli ಜಾಸ್ತಿ ಆದಾಗ the screening effect decrease ಆಗುತ್ತೆ. ಯಾವಾಗ screening effect decrease ಆಗುತ್ತೋ effective nuclear charge ಜಾಸ್ತಿ ಆಗುತ್ತೆ. Effective nuclear charge ಜಾಸ್ತಿ ಆಗುತ್ತೆ. Then it is strongly the outer electrons are strongly attracted by the nucleus. Therefore, the electron that is cloud is going to be shrinks. That is electron cloud is going to be shrinks. Therefore, the atomic size is going to be decreases. Atomic size is going to be decreases. What happens along the period? Atomic number is going to be increases. The atomic number is increases. The screening effect is decreases. Effective nuclear charge increases. Effective nuclear charge is increases. At that time, the outermost electrons strongly attracted by the nucleus, at that time the electron cloud is going to be shrinks, therefore the atomic size is going to be decreases. Atomic size is going to be decreases. Then down the period, down the group. Now we are going to be discussing about the down the group. When it comes to the down the group, that is electron is atomic number increases, but what happens? The electron is enters to the new shell. The electron is going to be enters to the new shell. At that time, that is going to be screening effect is going to be increases. The screening effect is going to be increases. Then effective nuclear charge is going to be decreases. Effective nuclear charge is going to be decreases. At that time, the electrons in the outermost shell, is loosely attracted by the nucleus. And loosely attracted by the nucleus. Therefore, the atomic size is going to be increases. Atomic size is going to be increases. Atomic size is going to be increases. Atomic size is going to be. Generally, we can say that the variation of atomic size is going to be decreases along a period and increases down the group. This you should be keep in mind. That is atomic size in the periodic, the variation of atomic size in the periodic table. If there are so many times answering this question in the examination, along the period it is going to be decreases, down the group it is going to be increases. That you should keep in mind. Next we will discuss about the ionic radius. That is what is meant by ionic radius? That is the ionic radius means. Now we will discuss about the ionic radius. That is ionic. What is meant by ionic radius means? That is the distance between the center of the nucleus. Distance between the center of the nucleus and the point at which the nucleus has its influence on the electron cloud is called as the ionic radius. Ionic radius is the distance between the center of the nucleus. Center of the nucleus and the point at which the nucleus has its influence on electron cloud is called as ionic radius. This the size of the cation. The size of the cation is less than its parent atom. Suppose example, if you are going to take the example, it is sodium. Then it's going to be removal of one electron. It's going to be from the ion. It's going to be from the cation. Means this having the 186 picometer. Then sodium ion having the 91 picometer. Means that is going to be, what happens? We know that the cation is formed by the removal of electron from the effective nuclear charge. The removal of electron from the effective nuclear charge. At that time, the electron cloud is going to be shrinks. Therefore, the size of the cation is going to be less. Size of the cation is going to be less. Here, the sodium, it is a parent atom. This is about the cation. The cation having the less, that is cation, size of the cation is less compared to the parent atom. Like that only, the size of the anion is going to be having that, the size of the anion is more than, that is this having suppose 99 picometer. The chlorine having that size of the chlorine is 99 picometer, but the size of the anion is having the 181 picometer. This is the example. the size of the anion is more than the size of the parent atom. This is because the anion is formed by that is gaining of one or more electrons. And therefore the electron cloud, the effective the electron is going to be added to the effective nuclear charge. It's going to be increases the effective nuclear charge. At that time, it's going to be the electron cloud is going to be expands. The electron cloud is going to be expands. Therefore, the size of the anion is going to be increases. This is about the ionic radius. The next we are going to be discussing about the isoelectronic species. This is very important. So many times asked in the examination. Isoelectronic species. When it comes to that isoelectronic species, what is meant by isoelectronic species? The atoms of different elements. The atoms of different elements contains the same number of electrons but different number of protons. That we call as a isoelectronic species. Very important. So many times asked in the examination. The isoelectronic species. What is isoelectronic species? Give an example. So many times asked in the examination for the 2 marks. What is meant by isoelectronic species? The atoms of the different elements. Suppose I take the example, that is nitrogen 3 minus. That is ions of the different atoms. That is 2 minus ions of the different atoms. This is the nitrogen. This is the oxygen. Then this is the fluorine. Then Na plus this is the sodium ion. Then magnesium ion. Mg2+. Then these all the ions. Electrons is number of electrons same iರುತ್ತೆ. In the all the that is either nitrogen anion, oxygen anion, or fluorine anion, sodium cation, or magnesium cation having the same number of electrons. Same number of electrons means it contains the 10 only. It contains the 10. Number of electrons in this is 10 only. But the number of protons is going to be varying. Number of protons is in this is having the protons 7. In this the number of protons is 8. In this number of protons is 9. In this number of protons is 11. In this number of protons is 12. Then how we are going to get that 10, 7? Then the anion is adding up the electron, means 7 plus 3 will get that 10. Like that only 8. That is going to be 8. The atomic number of the oxygen is 8. Therefore, it contains the 8 protons. Then 2 minus means adding up the 2 electrons. 8 plus 2, 10 electrons. Then 1 minus means the 1 electron is going to be adding. Then atomic number is 9. The number of protons is going to be 9. 9 plus 1, we are going to get 10 electrons. Like this only. Plus means that is removal of electrons. Atomic number of sodium is 11. Then removal of 1 electron, we are going to get 10. Atomic number of magnesium is 12. Removal of 2 electrons, we are going to get the 10. Means isoelectronic species means the ions of different elements. That is the ions of different elements having the same number of electrons but a different number of protons is called as a isoelectronic species.